Hey everyone, so I recently got some questions regarding binomial expansion, so I just decided let me solve them and kind of explain binomial expansion as we go. So what is binomial expansion? It's kind of an expansion, okay, expansion of an expression that involves two terms or two values, okay, two terms raised to a particular power. This is just my way of defining it. So it's expansion of an expression that involves two terms. So example, okay, two term example. So we have two terms a plus b raised to a particular power of, let's say, 2. Now, for most people, that will be easy. It will give you, a square plus 2ab plus b square. Fine. All right. If you have something like a plus b raised to power 3, again, a bit longer but not so complex. We have a cube plus 3a square b plus 3ab square plus b cube. So for most people, the binomial expansion of a plus b square, a plus b all cube, it's kind of easy. But when you start going to, let's say, a plus 4, a plus b raised to power 4, or a plus b, let's say, raised to power 7, and they ask you find the first term, so it becomes a bit more complex. So now, how do you do this? So just kind of explain, right? Supposing we have the term, supposing we have a value, let's say a plus b raised to power n. Okay, so how do we expand this? All right, I'm going to use the summation notation now. We have some, so we're going to have something like this. Okay, all right, sorry, something like this. Okay, you have r equals 0. Okay, n, which is the power of raising 2, and then n r a raised to power n minus r, then b raised to power r. So don't let this thing confuse you. It's just that, okay, we're gonna make we are going to find the sum of this. Okay, we're going to find the sum of this with r starting with 0. So this is the starting point. Sorry about my writing. And this is the end point. So we're going to start from when r is equal to 0 until we reach the point where r is equal to n. Okay, so let me actually do that. So let's try. Okay, let's try a plus b raised to power 4 now. Okay, a plus b raised to power 4. Our n here is 4. Okay, our n is 4, and then we're going to draw that. I'm going to put that notation sign again. So r always start from 0. So n here is 4. Okay, we have n cr. Okay, a raised to power n minus r and b raised to power r. Okay, so let's start from when r is equal to 0. Okay, so we're going to start from when, so we're going to be adding. So let's start from when r is equal to 0. So we have our n is 4. So 4. Okay, c, where's our r here? 0. Okay, dot, because we're multiplying. N minus r. Our r is still 0, and n remains 4. Okay, so that'll be 4 minus 0. Let me just write everything there. 4 minus 0 dot b 0. Okay, that's the first part. Now when r is 2, we continue, plus, sorry about my pens. I don't know why it's shaking like this. So next one will be 4 c. What comes after 0? 1. 4 c1 dot a raised to power 4 minus 1 p raised power 1. So that's just, so the notation should not scare you, honestly. It's just showing that we're going to start from when r is equal to 0, keep adding until r becomes n, so we're going to stop when r is 4. Okay, so plus bracket 4c2 dot a raised power 4 minus 2 dot p raised power 2. Okay, plus, all right, next one. So what's the second to the last 4c. So because of space, I'm just gonna make it, let me come in down here. 4c3 dot a raised power 4 minus 3 dot p raised power 3. Okay, that's the value of r. Plus the last one, when r and n are the same value, 4c4 dot a 4 minus 4 dot p 4. Okay, so that's just it. So this C just stands for combination, right? So if we have so that still stands for combination. So what does that mean? So we have NCR is equals to n factorial over n minus r factorial times r factorial. Okay, so you can either do it with your calculators or do it manually. Okay, you can either do it with your so let's just do it manually. Okay, so let's start with this one. Okay, so 4c0, all right, so I'm just gonna do the workings here. 4, that'll be 4 factorial, okay, divided by 4 minus 0 factorial, or 0 factorial. Now 0 factorial is 1, 4 minus 0 is 4, so we're just gonna get 1 here because 4 factorial divided by 4 factorial is 1. Okay, same thing, so we're left with 1 times 4 minus 0 here is 4, b raised power 0 is 1, so what we're left here is just a raised power 4. Okay, plus the next one. Okay, let me use my eraser. Okay, so if you want to use a calculator, you can use a calculator and just skip. All right, so 4c1 will be what? 4 factorial over 4 minus 1 factorial, 1 factorial. 1 factorial is 1, still 1. 4 minus 1 is 3. Okay, so it means that 4 factorial divided by 3 factorial. All right, so 4 factorial divided by 3 factorial is 4. Because 3 factorial is something as 3 times 2 times 1. We have 4 times 3 times 2 times 1. So this part goes. Okay. So we can also use that as a rule, something you can remember, and say that n factorial over n minus 1 factorial will always give you n. All right, so it's something you can also use to be quick when you're solving math. So our answer here is what? 4. Okay, let me put the 4 here. 4. All right. 4 minus 1 is 3. Okay, and b raised power 1 is 2b. So we have a3p. All right, so we're making progress. So we have 4c2. So it's just the same thing. Okay, so I'm just going to erase this. I'm just going to, okay, so we have 4 factorial over 4 minus 2 factorial 2 factorial. Okay, so what we'll have here is okay, so what we have here is what do you call it? 4. So 4 minus 2 is 2. So we have 4 factorial over 2 factorial times 2 factorial. Okay, so since this is 4, 2 factorial is something as 2 times 1. If we open this, it's something as 4 times 3 times 2 factorial. So 1, 2 factorial cancel out 2 factorial. So I left with 4 times 3 over 2 factorial, which is something as 2 times 1. 2 here goes 2, so I left, so 2 times 3 here is 6. Okay, 6. And then what is the power of a? 4 minus 2, that's 2. Okay, b raised power 2. Okay, we're getting somewhere. Plus, all right, we're getting closer. In the second to last, so 4c3. Okay, 4c3, so that's will be 4 factorial over 4 minus 3 factorial, 3 factorial, which is, okay, 4 minus 3 factorial. 4 minus 3 is 1, so 1 factorial is still 1. All right, so we're left with 4 factorial over 3 factorial, which is something as 4 times 3 factorial, because if we go 4 times 3 times 2 times 1, yeah. So this can cancel this again, so we're left with 4. So 4, what's the power of a now? At this point, 4 minus 3 is 1, so that's a raised power 1, or just a. And then we have b raised power 3. Okay, and lastly, 4c4. Now, when you have something like this, okay, when you have NCN, so yeah, let me just erase this again quickly. So whenever you have NCN, let me just say 4c4, okay, which is something as 4 factorial over 4 minus 4 factorial, 4 factorial. Okay, 4 minus 4 gives you this 0. 0 factorial is still 1. 4 factorial divided by 4 factorial will give you 1. So whenever you have this, just know that, the answer will always be 1. 4 factorial, NCN is just 1. So if you have 5c5, okay, so the C stands for combination actually. Okay, so whenever you have that, you just know that the answer is going to be 1. So it kind of helps you to be fast when you're writing an exam. Okay, so things like this, all these rules, so you give yourself some rules so that when you just see the situation, boom, you move faster. So for C4, that'll be 1. Okay, so we're left with 4 minus 4 is 0. So a raised power 0 will be 1. Anything raised power 0 is 1. So I'm left with b raised power 4. So it means if we expand, so it means that if we expand this, if we expand, so I'm looking for my pen. Yeah. So if we expand a plus b raised power 4, okay, we have a raised power 4 plus 4a cubed b plus 6a squared b squared plus 4a b3 plus b4. So yeah, this is so we have 1, 2, 3, 4, 5, right? So some things you can use to check if you're correct. That example, now we raised it to the power 4. So if you have something like this, we expect to have 5 terms. Okay, right? If I have just like, let me go back up when I had, now when I wrote a plus b raised power 2, you can see we had 3 terms. Okay, that's 2 plus 1, 3. When we raised a plus b to the power 3, we had 1, 2, 3, 4. 4 terms. So a plus b raised power 4, I'm expecting it to have 5 terms. Okay, so and I counted it here. 1, 2, 3, 4, 5. Okay, and then there are also some other things you can observe, but I won't go deep go deep into them because they can change depending on the values of A and B. Okay, but you can see at least we have 5 terms here. Everything here is correct. So let me just go to the questions I got. Okay, because of time, let me just quickly go down. Okay, let me go down to the question I got, and then let's see how we can tackle them. So the first one I got was wait, let me see. Let me try and copy it here. Let me write number 1. Something like this. Now expand this. We have 2m minus 9 raised to power 5. Okay, so raised to power 5, we're expecting 6 terms. Okay, we have 2m minus 9 raised to power 5. Okay, so let's just remember our formula when you use a plus b raised to power n. Okay, we use summation. We'll start from when r is equal to 0 and n is n c r. Okay, a n minus r b raised to power r. So our a here, so let's look at our a here is 2m. Our b now is going to be minus 9, okay, because here we use a plus b. So our b here is actually going to be minus 9. And our n is 5, and our r always starts from 0. Those are the things we need to know, and then from there we'll be able to expand this. So let's expand. Let's expand. So we have 2m minus 9 is power 5. Okay, starting from when r equals to 0. So we have where's our n? 5. So we have 5c0 dot 2m, because it's 2m together. Okay, raised power 5 minus 0 dot minus 9. Okay, raised power 0. Okay, right, so we have 5c0 dot 2m plus dot minus 9 raised power 0. Okay, sorry about my pen. I'm trying to make it. Let me see if I can adjust it so it's smoother. Okay, plus, let's continue. Go to 5c1, okay, dot 2m. So 5 minus 1. So let's try and be faster now. 5 minus 1 will be 4. Then dot minus 9 raised power 1, because our r is 1 here. Okay, right, plus next one, 5c2 dot 2m going to be raised power 5 minus 2. 5 minus 2 is going to be 3. Dot minus 9 raised power, what's our r here? 2. Okay, you can also use it as your reference. Okay. Sorry. All right, plus. Okay, plus well, we're now 5c3. So we'll just keep on going until r reaches the value of 5. So it's long, but it's still shorter than having to open the bracket and open the bracket and open the bracket. You just spend a long time. Okay, 5c3 dot 2m raised power 5 minus 3, which is 2. So we're getting closer to the end. Dot minus 9 raised power 3. Right, plus 5c4 2m raised power 5 minus 4, which is 1, so we can ignore the 1, or let's just put it there so we don't make any mistakes. 1 Now it's minus 9 raised to the power 4. Okay. Plus, okay, plus what I'm left with 5 C5 dot, okay, 2m raised to the power 0, because that's 5 minus 5 dot minus 9 is power, where's our r? 5. Okay, so I advise at this time, if you want to do it manually, I mean, maybe if you're being asked to do it manually, fine. But though I'll recommend, just doing it with the calculator. So this time I'll do it with the calculator because we have so many numbers. All right, so let me create space. I have so many numbers now. All right, so I'm just gonna tell you what I do on the calculator. So 5C0, so let's start with this one. Make sure I make it thick if I can. Okay, let's start with 5C0 now. 5C0 is going to give me 1, all right? Okay. And then 1, now 2m raised to the power 5. Okay, so it's going to be 2 raised to the power 5, which is 2 raised to the power 5, which is 32. Okay, so we have 32 m5. Okay, we're going to start with 32 m5. 5C0 is 1. Okay, 5C0 is 1. Okay, plus, what's the next one? 5C1, okay, 5C1 on my calculator, that will give me 5, okay, that will give me 5, 5 times 2m raised to the power 4, so that will be 2 raised to the power 4, which is 16, m raised to the power 4, which is m raised to the power 4, times, let's say, 16 m4. Then we have this minus 9 here times minus 9. Okay, plus the next one was 5C2. 5C2. Give me the value of 10. Okay. So I have 10 times 2m raised to the power 3. 2 raised to the power 3 is 8. So we have 8 m raised to the power 3 times minus 9 squared, that is 81. So the square of a negative number will give you a positive number. So we have 81. Okay. Plus. So we're expecting to have 6 terms here. Okay. So let me come down here. Okay. So we have 1, 2, 3. Okay. Now we're here. 5C3 is also 10. Okay. So I have 10 times 2m raised to the power 2. So we have 2 raised to the power 2 is 4. M is the m square. M raised to the power 2 is the m square. Times minus 9 raised to the power 3. Raised to the power 3, that will be minus 279. Minus 729, sorry. 729. Okay. Maybe I should have just done it. Oh, it doesn't matter. Plus, okay, where are we? 5C4, that's 5. Times 2m raised to the power 1. And you can see 2m raised to the power 1, which is 2m. times minus 9 raised to the power 4. So because it's an even power, it's going to be positive again, which is 6, 5, 6, 1. Okay, and lastly, plus 5C5, NCN 1, 2m raised to the power 0, everything raised to the power 0 is 1, so I left it minus 9 raised to the power 5, 9 raised to the power 5, which is actually a very large number. It's minus 5, 9, 0, 4, 9. That's a okay. Okay, so now we just have to complete it. Okay, so we're left with so let's see. Let's try and have 32 raised to the power 5 plus. So we have 5 times 16. 5 times 16. Okay, times minus 9. So that'll be minus 720. So we can remove this plus here. It's going to be a minus 720 m raised to the power 4. Okay. Plus, okay, so 10 times 8 times 81. 10 times 8 times 81. That'll be 6480. So we have 6480 m cube. All right, plus. So since we're going to have a minus here, we can just put a minus here. So we have 10 times 4 times 729. 10 times 4 times 729. Just going to give us trying to find my pen. Okay, so we have 29160. Okay, m squared plus we have 5 times 2 times 6561. All right, which is 65610. Okay. In an exam, I'll most definitely be faster than this, just because I'm trying to explain. So 65610. Where's the coefficient here? M. Let's have M. Lastly, minus sorry, I'm looking for my just looking for my pen. Okay, there it is. So that minus 59049. Okay, so that'll be our answer. It's long. I mean, there are big numbers here, but sometimes they ask these questions and you just have to answer them, no matter how big numbers are. Okay, so this will be answer. All right, so this will be answer. Our answer is so let me reiterate. So we have the 2 m raised to the power 5 minus 720 m raised to the power 4 plus 6480 m raised to the power 3 minus 29,160 m squared plus 65,610 m minus 59,049. Well, that's a large value. Or those are large values rather. Okay, so All right, so I think that now that'll be this for now. Okay, so let me go. So be able to go to the next question very soon. Okay, but okay. So what I did, I just let me see. I just went so you can check if it's true. So there's this site we call symbolab.com. So I usually use it so just to cross check and show that my method was correct. All right, so this is our value here. We have 32, 720, 648. All right, so I went to Symbol Lab and just you can use it to cross check, maybe if you're doing an assignment online and stuff like that. So it won't solve everything for you. Okay, but you just to make sure that you yourself, are confident in your answers. So I went there and just so it showed me. I'm just gonna show you this one. Just copy this and let's check if it's correct. Okay. So let's see. So this is 2m minus 9, right? So let's see. 32m5, yeah. 720m4, yeah. 648m plus 648. Be careful of the signs, yeah. Minus 29160, yeah, correct. Plus 65610m, yeah, correct. Minus 5900. So you can see this is how you can solve these questions with binomial expansions. It's not difficult actually, but it just takes a long time. That's all. It takes a long time, but it's not difficult. So if there's still more questions I got, but because of the length of the video, I'll stop here for now. Thank you, and I'm coming back with more.